Hi team, welcome to Wiggins Maths. In this video we will be looking at integration by substitution. It's another fantastic approach to integrating more complicated functions. As always, do not neglect the formula booklet. Okay, so I just want to run through the process of integrating by substitution. More often than not, you are given the substitution to begin with. We'll look at an example later of when you're not, but normally you are. So what we'd like to do first is we'd like to differentiate this with respect to x. Then we're going to make dx the subject. We're also going to make the function of x the subject just in case. Then we're going to substitute it in, simplify it, integrate it, and finally, and very, very importantly, then rewrite back in terms of x. Okay, so let's do it. So the first thing we wanted to do was we wanted to differentiate with respect to x, make dx the subject, make the function of x the subject, substitute in here, I could have written this as root u, but I know it's going to be easier to write it as u to the power of a half. And then dx was du over 3. Okay, let's tidy this up ever so slightly. So that's u to the 3 over 2 over 9, add 2u to the half over 9 with respect to u. Now we have a function that is a lot easier to integrate. So let's do that. So this will become u to the 5 over 2, divide by 5 over 2 becomes 2 over 45. And we're going to integrate this term, so u to the 3 over 2, and that is going to become 4 over 27 when we divide by 3 over 2, plus c, of course. And then our final step was to then rewrite it back in terms of x. And there you have it. We've integrated this successfully now. There are other approaches which we can look at a later time, but substitution is a really nice, effective way of integrating slightly more complicated functions. So let's try this one. Yuck. Looks disgusting. So let's do this. Let's do this by substitution. First step, we are told the substitution. So let's write that down. And then we can make dx the subject. And then I'm also going to make the function of x the subject. Lovely. So cos x, there's no way of writing cos x at the moment. Sin x was u subtract 1. 1 plus sin x is u, and dx is du over cos x. Lovely. Cancels out. So that's left us with the integral of u to the power 4 subtract u cubed with respect to u. So something that is actually simple to integrate. Final step, back in terms of x. Lovely. Okay, so we're on the trig lookout. This time substitution is in terms of u. So it's slightly different to what we've done so far. However, the process will remain exactly the same to a certain degree. Okay, so dx by du is going to be sec squared u. Formula booklet if you are unsure. Okay, so dx, the subject, so that is going to be sec squared u du. So let's substitute into this and sort of hope for the best at this point. So 1 plus tan squared u, and then we've got sec squared u du. Okay, 1 plus tan squared u, we know 1 plus tan squared u. Okay, it's just a reminder down here, sine squared u plus cos squared u equals 1. So tan squared u plus 1 equals sec squared u. So let's rewrite this. 1 over sec squared u multiplied by sec squared u du. Ah, okay, so they cancel. So is this really asking me to integrate 1? Looks like it. So that is u plus c. Ah, can we see the problem? We know what x is. We don't know what u is. So we need to find out what u is, need to make u the subject. So actually here, I'm going to write it like this. Bah, don't like it. I'm going to write it in a slightly better way. That's much better. There we are. So who'd have thought that was the integral of this is arc tan x plus the constant. So be on the lookout for those when you can use trig identities. So what about definite integrals? It's the same process, just a couple of minor tweaks. So for example, we'll need to change the limits if we are going to integrate using u. We could integrate and then put it back in terms of x, and then we don't need to change the limits, but that can be a little bit of a faff. And then our final step is, of course, to evaluate the integral. So here we go. Let's do this. Let's sort out those limits in a moment. So how do we sort out these limits? Well, these are what we'd substitute in for x, aren't they? So here we can say for u equals 2 plus 1. So u is 3, that is my upper limit. And u is equal to 0 plus 1. So u is 1 for our lower limit. So now we have our change of limits. So then let's just tidy this up ever so slightly. So that's now the integral between 3 and 1. U to the power 4 subtract u cubed du. Now the beauty of changing the limits is now we do not need to worry about rewriting in terms of x at the end, because it's going to evaluate to give the same value. So and that works out to be 142 over 5. Okay, so that is the value of that integral, whether it was in terms of x or in terms of u, the same value. Okay, this one, notice that the limits are in radians. Whenever we're using calculus with trigonometry, it only holds if the input is in radians. So du by dx is negative sine x. So du over negative sine x equals dx. And u subtract 1 is equal to cos x, just in case that is of any use to us. Should we sort the limits as well? So u equals cos pi over 2 plus 1. So in that case, cos of pi over 2 is cos 90, which is 0. Add 1 is 1. And then for the other, cos 0 add 1, well, cos 0 is 1, add 1 is 2. So now we're going to integrate between 1 and 2. I could have done it between 2 and 1, we'll get the same magnitude, of course. So one might be a negative answer, one might be a positive answer. So e to the u, and then can't write sine x just yet, but dx luckily is du over negative sine x. So they cancel out. I then need to make sure that I'm looking at the negative. So it's e to the u du. When I integrate it, it becomes e to the u. And when I evaluate this, I end up with 4.67 to 3 significant figures. But worth noting, as an exact value, it would be e squared subtract e. Okay. Now this one's a little bit different. The substitution we are given still, but it's in terms of u squared. Okay, it's exactly the same idea. We're going to have to differentiate first, but we're going to have to differentiate this implicitly. Okay, so u squared with respect to x is going to be 2u du by dx, and that is equal to 2. So u du is equal to dx. Okay. Also worth pointing out that x is equal to u squared add 1 over 2, just in case that's useful. We can also sort out these limits, can't we? Now, I need to mention about these limits. When we square root, surely we need to think about whether it's positive or negative. The thing that you need to be aware of is as long as you are consistent, you'll end up with the same magnitude. Okay, so I tend to use the positive roots just because it's easier to work with for me. If you chose the negative roots, absolutely fine. You'll just end up with a negative answer, but the same magnitude. Okay, so my limits are now 3 and 1, or negative 3 and negative 1. So let's integrate. Blimey, should we have a look at this then? 3x, so that is 3 lots of u squared add 1 over 2, all over, if that is u squared, the square root of u squared is just u, and then u du, so the u's cancel each other out. So we're integrating, the limits were 3 and 1, and if I was to expand this now, it'd be 3u squared over 2 add 3 over 2 du, which is something that is a lot easier to integrate. So it's going to be u cubed over 2 plus 3u over 2 between the limits of 3 and 1. Substitute these in. And when you evaluate that, you end up with 16. Sort of rule of thumb here, if you end up with an answer like 16, you're probably correct. If you end up with a lovely whole number answer like that, you're probably not going to fluke it. Okay, one final example. Okay, so hopefully you can spot what's different about this one, and that is we have not been given the substitution. Ouch. Okay, so the rule that you should follow here, generally speaking, is you should substitute the awkward bit. So here is the awkward bit. So I'm going to set u as 1 plus sine x. And then we go through as normal. I'm not going to make sine x the subject here. It's not going to be of any use. So integrate. Okay, so it's just u to the half du, which is u to the 3 over 2, 2/3 plus c, and then finally substitute back in our u. Whew, we made it. Okay, so if you found this video useful, of course, please subscribe, tell your peers, and I'll be aiming to upload new videos each week to ensure that we are as successful as possible. And of course, amateurs call it genius, masters call it practice.